Let us see the next problem in the interpolation, that is find the interpolating polynomial f of x satisfying f of 0 is equal to 0, f of 2 is equal to 4, f of 4 is equal to 56, and f of 6 is equal to 204, f of 8 is equal to 496, and f of 10 is equal to 980. And hence find f of 3, f of 5, and f of 7. See, when they are asking you to find the interpolating polynomial, you have to find the interpolating polynomial itself. Directly you should not find f of 3 and f of 5 and f of 7. Whatever the point they are asking, directly you should not find this. First and foremost thing, you have to find this interpolating polynomial. By using this interpolating polynomial, you have to find f of 3, whatever the given point, f of 3, f of 5, and f of 7 we have to find. Okay, to find the interpolating polynomial, it is not restricted that you have to use forward or the backward interpolation formula. Whichever is convenient for you, you can use. See, to find the interpolating polynomial, we can use any of the forward and backward interpolation formula. Whichever is convenient for you, you can use that. So if you are using forward interpolation formula, the corresponding forward difference table you have to construct. If you are using backward interpolation formula, the corresponding backward difference table you have to construct. That's all. Anyway, you know how to construct the difference table, that is forward difference table and the backward difference table. Now I am using forward interpolation formula here. I'm using forward interpolation formula here. See, we have Newton's forward interpolation formula. You know this formula. Yp is equal to y naught plus p into del y naught plus p into p minus 1 divided by 2 factorial into del square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial into del cube y naught plus p into p minus 1 into p minus 2 into p minus 3 divided by 4 factorial into del power 4 y naught plus so on. See, this is a formula. This is a forward interpolation formula. You know. See, for this corresponding difference table, you have to construct. The corresponding difference table means for the forward difference table. You know how to construct this difference table. How I have constructed this difference table. See, f of 0 is equal to 0, f of 2 is equal to 4, f of 4 is equal to 56. Likewise, the values are given. See, the values inside this bracket, those are x values. So 0, the first value of x is 0, 0, 2, 4, 6, 8, 10. 0, 2, 4, 6, 8, 10. These are x values, and the values of y, these are the values of y. Corresponding values of y are this 0, 4, 56, 204, 496, and 980. These are the values of y. Now you know how to find these differences: first difference, second difference, third difference, fourth difference, and fifth difference. Here it is fifth difference. Till fifth difference we have got the value. Okay, that is not a matter. Now you know how to find this difference table. You know how to find this difference table, right? See, this is the difference. 4 minus 0 is 4. 56 minus 4 is 52. 204 minus 56 is 148. 496 minus 204 is this. Similarly, this. For the next difference, 52 minus 4 is this. 148 minus 52 is this. 292 minus 148 is this. Similarly, the terms is found. Now let us find the value of p here. See, here we have p, right? What is the value of p? P is given by actually x minus x naught divided by h. Okay, for this, let us substitute the particulars. Here x value, what is the value of x? Actually, we have to find these values of x. See, values of y at this point, that is at this point means 3, 5, 7. At these points, we have to find the value of y. See, actually I have to put 3 in place of x. So, but I should not put, because first we have to find the interpolating polynomial. What is the interpolating polynomial? To find the interpolating polynomial, in place of x, put x only. You should not put any of the value which is given here. Okay, so x place is x only. X naught, what is x naught? X naught is the initial value of x. Initial value of x is 0. 0, put 0 in place of x naught, it is 0. And h is the step length or the length of the interval. What is the length of the interval? In the first interval, 0 to 2. The second interval, 2 to 4. What is the length of the intervals? The length of the intervals here it is 2. See, from 2 to 1, 2 minus 0 is 2. 4 minus 2 is 2. 6 minus 4 is 2 again. See, the common length is 2. This is a common length or the step length. So it is 2. So x minus 0 by 2 is x by 2. So p value is x by 2 we got. Now substitute this p value x by 2 in this formula, and since we are using forward interpolation formula, we have to use this leading forward differences. We have to use these leading forward differences in the formula. See, y naught is 0, plus p value is x by 2 into del y naught. What is this del y naught? What is this del y naught? Del y naught from the table. Del y naught. This is del y naught. Del y naught is 4 plus p into p minus 1 by 2 factorial. That is x by 2 into x by 2 minus 1 divided by 2 factorial into del square y naught. What is this del square y naught? Del square y naught is 48 plus p into p minus 1 into p minus 2 divided by 3 factorial. That is x by 2 into x by 2 minus 1 into x by 2 minus 2 divided by 3 factorial is 6. Okay, what is this del cube y naught? Del cube y naught is 48 plus the next value is 0 and the next value is again 0. So anyway, if it is multiplied, we will get 0 only. So the next value again, the two terms will become 0. So that's why directly I have written zeros here. Now let us simplify this term. So when you simplify this, see 2 1s are 2 2s are 4, so that is 2x plus x by 2. Okay, here 2 factorial is nothing but 2. 2 1s are 2, 4, 24s are 48. Again this 24 will be cancelled with this 2. See 2 1s are 2 12s are 24. Now you have 12 into x, 12x into x by 2 minus 1. These are the terms, these terms are remaining. Plus next, here 3 factorial is 6. 6 8s are 48. You have 8 here. 6 8s are 48. It is cancelled. 6 8s are 48 and 2 4s are 8. Now we have 4x into these are the two terms remaining written as it is. Now let us simplify this step. So 2x as it is plus here 12x also written as it is. Now let us simplify this. X by 2 minus 1 is nothing but can be just cross multiply. That is x minus 2 divided by the LCM is 2. You have taken the LCM here, that's all. All other terms are written same. Now 4x as it is, take the LCM here so that you will get x minus 2 divided by 2. For this term, you will get x by 4 minus 2. 2 2s are 4. X minus 4 divided by 2. When you take LCM, you will get these two terms. Okay. Now see 2 1s are 2, 2 2s are 4. Again 2 1s are, that 2 will get cancelled. Now here 2 1s are 2 6 are 12. What are the remaining terms? 2x plus 6 into x is 6x, x minus 2 written as it is, plus here it is only x is remaining, x into x minus 2 into x minus 4 is remaining. Now here 2x written as it is, plus 6x into x is 6x square, plus into minus is minus, 6 2s are 12x, plus x written as it is, multiply these two terms, so it is x into x is x square, minus 2 into x is minus 2x, minus 4 into x is minus 4x, so minus 4x into minus 2x is minus 6x, plus minus into minus is plus, 2 4s are 8. When you simplify these two, you will get these terms. Now multiply these terms, all other terms written same. Now x into x square is x cube, minus 6 into x is 6x square, plus 8 into x is 8x. Now here minus 6x square plus 6x square will get cancel each other. Now you have these terms. Let us simplify these terms. So x square is a higher order term written first. Then minus 12x is there. 8x plus 2x is there. 8x plus 2x is 10x. 10x minus 12x is minus 2x. So this is the polynomial we have. So this is the required interpolating polynomial that we have to find. Now for this interpolating polynomial, we have to substitute these values. So in place of x, let us substitute 3 in the first case. In the second case, substitute 5. In the third case, substitute 7. So that the corresponding values of f of 3, f of 5 and f of 7 you will get. That is written here. See, in place of x, put 3, 5 and 7. Okay. So for this polynomial, so in the first case I have put x is equal to 3, f of 3 is equal to, in place of x it is 3, 3 cube minus 2 into x plus 3, 3 2 is a 6, 3 cube is 3 cube is 27, 27 minus 6 is 21. Similarly, in place of x 5, put 5. So f of 5 is equal to 5 cube minus 2 into 5. So you will get 115. Similarly, in place of x 7. So when you put 7, f of 7 is equal to 7 cube minus 2 into, in place of x is 7, 2 into 7. So you will get 329. See here, to check whether the found interpolating polynomial, whether the found interpolating polynomial is correct or not, you can check like this. See, just put, see, the interpolating polynomial can be cross verified by substituting the values of x is equal to 0, 2, 4, 6, 8, 10, so on. The corresponding values of y you will be obtained. See, for this interpolating polynomial, put x is equal to 0. See, what is the polynomial we have here? F of x is equal to x cube minus 2x is there. This is the interpolating polynomial we got. For this one, put x is equal to 0 because the first value of x is 0, na? So put x is equal to 0. 0 cube minus 2 into 0. So what it is? It is 0. So f of 0 is 0. Yes, it is correct. Now we can check any other value by taking any other value. Okay, I will take 4. So what is f of 4? F of 4 is equal to 4 cube minus 2 into 4. Okay, 64 minus 8. 64 minus 8 is 56. So f of 4 is 56. So this is how we can cross verify the values